So lesson 3.3 is on proofs with parallel lines. And one of the things I asked you to do was on the back of your yellow sheet, I asked you to write down these theorems. So we'll save ourselves a whole lot of time that we don't have to do this in class. But I want to explain how these theorems work. Okay, question? What's that? I'm recording. Okay, it's okay. Okay, it's okay. So here we go. So when we have our theorems, like the corresponding angles theorem, that theorem said that if two parallel lines are cut by a transversal, and you don't have to write this down, it's already on your yellow sheet. Then corresponding angles are congruent. So that was our initial theorem. It's one of the ones that we have on our blue sheet. Okay. We also had one that said if two parallel lines are cut by a transversal, then alternate interior angles are congruent. And if two parallel lines are cut by a transversal, alternate exterior angles are congruent. And if two parallel lines are cut by a transversal, corresponding angles are supplementary. And you guys know those. You've shown me that you know those. Now what this section is about is called the converses of these parallel line theorems. Okay? So remind me, when we had a conditional statement and we wanted to find the converse, what did we do? We switched them. We switched the order. But this is one of those times when we have to add some words to make it make sense. Because if we just switched it and said if two corresponding angles are congruent, then two parallel lines are cut by a transversal, that won't make a whole lot of sense. So we add a few words, and our theorems that you have written down in the back of your sheet should say if two lines are cut by a transversal, so corresponding angles are equal, then the lines are parallel. Okay, so these things are already probably in your notes. But I wanted to explain why we added the extra words. It helps make it make sense. Okay? So if two lines are cut by a transversal, so alternate exterior angles are congruent, then that forces those lines to be parallel. If we have two lines cut by a transversal and alternate exterior angles are congruent, then those lines have to be parallel. And if we have two lines cut by a transversal and consecutive interior angles are supplementary, that makes those lines parallel. Okay? So we're doing the converse of what we did on Friday today. Questions on this slide? Okay, so let's talk about those. So here we have two lines. This is where you start writing things down. So draw your two lines that look like they're parallel, but notice we don't have any symbols to show that those lines are parallel. Okay, so we've got two lines that look like they're parallel, but there are no symbols indicating that. And we have a transversal. Okay, in the upper right, I want you to write your 72-degree angle in there. And in your bottom right, I want you to put 4 parentheses x minus 5. Close parentheses. That means parallel. That new symbol, the double lines, means parallel. So we want to figure out what value of x will make those lines be parallel. That's our goal. So what value of x makes those lines parallel? So first of all, we have to ask ourselves if this is any special relationship that we know from our blue foldable. I see 72 on the outside of those lines, right? And I see this 4 times the quantity x minus 5 on the outside of those lines. So everyone agree that's exterior? Each of those are exterior angles, okay? But are they alternate exterior? No. They're consecutive exterior. And we didn't ask you to remember anything about consecutive exterior, did we? Okay. But we know something about corresponding, don't we? Which one would be corresponding to 72? Mm-hmm. Right. So we could make this one 72, or alternate exterior angles are congruent, aren't they? So we could write a 72 down here. Okay? If we make these alternate exterior angles congruent, then that can force x to be a number that makes those lines parallel. Okay? So what would my equation say? Is it going to be equal to 72? Plus 72 equals 180. Why? They form a straight line. Linear pairs are supplementary, aren't they? Okay, very good. So now we have to do what to be able to solve this problem? Distribute. So we distribute the 4 to both. Now I see things that are alike on the same side of the equation, right? So I want to combine those like terms first. So 4x, be careful, one's negative, one's positive. So we're going to subtract and give it the positive sign. So 52, right? And then minus 52 from both sides. And we'll get 128. So what's x? 32. So when x is 32, our alternate exterior angles are equal, and that forces those lines to be parallel. Okay? Okay? Because x is 32 now, we set it up to make those lines have to be parallel. What questions do you have on this slide? We feel good about this one? All right. So one quick last example. If this one goes well and you don't need to see another one, we'll only do one proof today. Okay? So let's quickly draw the two lines that look like they're parallel, G and H. Draw your transversal T. And we're trying not to distract you with too many angles. So just write angles 3 and 4 on the interior of those lines, and 5 and 7 on the other side, in the bottom left. And our goal is to prove that alternate interior angles converse. So we're trying to prove that if two lines are cut by a transversal so that the alternate interior angles are congruent, those lines will have to be parallel. And we're trying to do that without using any vertical angles. So we only get to use the angles that they've numbered for us. Okay. So they told us that those two angles, those alternate interior angles, are congruent. 4 and 5 are congruent. Okay. Since 4 and 5 are congruent, we want to make sure we make our marks on our drawing. That's the best thing you can do to help yourself. So 4 and 5 are congruent. Okay. So we think maybe 3 and 7 are as well, right? If we can prove 3 and 7 are, then we have corresponding angles congruent. 4 and 7 would be, 3 and 7 would be corresponding. 4 and 7, we don't have a special name for. We don't have a name for them, so we're not sure. Okay? But if we can get 3 and 7 congruent, then we can get the lines parallel. And then that means that we've proven alternate exterior angles converse. Or sorry, alternate interior angle converse. Okay? So where do you want to start? Maya. So we're going to use the ones that we have. Okay. What do we know about 3 and 4? They're 180. They add to 180. Okay? So they form a straight angle. So measure of angle 3 and the measure of angle 4 is 180 because because linear pairs are supplementary, right? Can we say the same thing about 5 and 7? Okay. Measure of angle 5 plus the measure of angle 7 is also 180. Same reason. It is a lot of writing. But the great news is that when we have 180, each of them equal to 180, shouldn't they be equal to each other? Okay. So the measure of angle 3 plus the measure of angle 4 is the measure of angle 5 plus the measure of angle 7. Why can we do that? They're equal, so we have 2 equal players and we want to put one in the game, so we say substitution, right? Good, because if 4 is equal to 5, we can say measure of angle 3 plus measure of angle 5 now equals the measure of angle 5 plus the measure of angle 7. Same reason. We just subbed it in. You could put a straight angle is typically one angle without any ray that goes through it. I know where you're going with that, but linear pair is a better answer. Technically, yes, but I probably wouldn't count it wrong because I know where you're going with it. The measure of a straight angle is 180 degrees, but typically a straight angle is made by 2 opposite rays with no extra ray in the middle. Okay. All right, so we're close, right? But what do they both have in common? A 5. So can we get rid of it? Why can we get rid of it? Good. And so how did we remove that angle 5 from each? We subtracted. Okay. And since 3 and 5 are 3 and 7 are congruent, what kind of angles are those? One's inside, one's outside. They're on the same side, so consecutive, but we don't have a consecutive inside-outside, right? Starts with a C, though. Corresponding. Okay? Since corresponding angles are congruent, then the lines have to be parallel. So our reason for this can be subtraction property of equality. Okay? And since our corresponding angles are congruent, we can use its converse. That says that if we have lines that are cut by a transversal and our corresponding angles are congruent, then those lines have to be parallel. And now we can use the alternate interior angle converse from here on out. Okay. Yep. So that's the corresponding angles. We found out that 3 and 7 were congruent, so that forces those lines to be parallel. And therefore, when 4 and 5 are congruent, we now have proven alternate interior angles converse. Thumbs up. Everybody okay, or do you have questions about this one? Sideways? I expect to see some sideways, okay? But you guys know your angle relationships, which is good. All right, do you want to see one more proof, or are you okay with that? Okay, we'll give you time to work and you can ask questions when we're walking our way through. Okay? Now I have one more thing to show you, and then you don't have to write this down. You don't have to write it down. But here is an example of something that you've written in your notes. We have something called the transitive property of parallel lines. Okay? And what it says is we have each parking space in a lot defined by two parallel lines. We see this all the time everywhere we go. And those lines share a common line with the next adjacent space. So explain why the left line in space 2, why line, I'm going to call it line A so I don't run out of enough lines. Why is line A parallel to the right line in space 8? Well, if this is line B and this is line C and this is D and E and F and G and H, why is line A parallel to line H? Yes, sir. They're all straight lines, right? And they're all parallel, right? So we have something called the transitive property. So rather than having to say A is parallel to line B and line B is parallel to line C and so forth and so forth and so forth, right? We can cut to the chase and just say then line A is parallel to line H by the transitive property of parallel lines. Okay? Because we could eliminate line B's here and say, well, that means line A is parallel to line C. Okay? But we could say C is parallel to D, so that means A has to be parallel to D. But D is parallel to E, so A has to be parallel to E. And E is parallel to F, so A has to be parallel to F. Can you see how long and tedious that would get? So we just say you can use the transitive property for parallel lines. Okay? All right, so your assignment for tomorrow, this is section 3.3, so we have 3.1, 3.2, 3.3 we've talked about and worked on. We're going to try to get as much done in class as possible on page 142, 1, 2 through 8 even, 12 through 30 even, 33, 35, and 41 to 42, 44. This is due on Tuesday, tomorrow, okay? And then if you have time tonight, get your distance formula distance from a point to a line from page 148 into your yellow sheet or your notes, and linear pair perpendicular, perpendicular transversal, and lines perpendicular to a transversal, page 150 in there. If you don't get those done, I'll remind you tomorrow, and I'll remind you on Wednesday, because these aren't due until Thursday. We've got to have some time to review 3.1 to 3.3, and then also to quiz over 3.1 to 3.3. So this stuff needs to go in your notes by Thursday.